them should be okay, and I'm happy to help you. Now, when you get to 11 and 15, those kind of get a little weird because you're like, well, how am I supposed to do this when I'm not looking at the function? Totally understand. You want me to start at 11?
Yes, please.
Okay. What we want to understand is that we only want to go with what they tell us, right? You know how the old adage is, don't assume. We can make conclusions, we just don't want to assume. So on number 11, they don't tell me anything about my function other than it's continuous between -5 and 5. Now before we do anything else, let's review just a quick walk down memory lane. You guys know what y equals x squared looks like. No big deal there. Do you remember what happens when you do shifting graphs and do something like putting like a +3 at the end of your graph? Moves your graph up 3 units. Okay. So this would make the graph go up 3 units. Do you guys remember what happens when you put something like x minus 4 on the inside? That moves it to the right 4. Exactly correct. Okay. Those things are going to play a role in your number 11. Okay? Even though you're like, how are they going to play a role? I still don't know what my number 11 is. I promise they will play a role in it. So they've got a picture where they're thinking of a function that's continuous between -5 and 5. And I don't know exactly what the graph looks like. So let's just go ahead and draw. No, I don't want to draw it like that. All I know, for example, is it does something, I don't know what it does. But it says it's continuous between -5 and 5. But the given information that you guys are being told is this. Now, being that this is day 2 of looking at this kind of notation, I want you to tell me, I know that's calculus speak, so it looks like calculus language, which it absolutely is. What does this tell you about your graph? The area under just this area right over here, right? This area is, and by the way, they gave me an answer, they said 4. So just the right side is 4. Do we agree with that? I think sometimes a picture is a good thing to do here. Okay, so when we get to part A says, all right, even though you don't know your function, what they want you to do is to consider what happens if you take your function and add 2 to it. Well, I did the little review with you over here with your functions as far as parabolas, because if you add 2 to any function, what's it do to any function? Shifts it up 2. So if I were to take my graph, and I'll just try to wing the same graph, but if I were to shift it up 2, then that's going to make what used to be my x-axis behave like 2, right? And then I'm going to try my best to draw that same kind of shape. Okay, that's supposed to be exactly symmetric to that. If you guys are all right with that idea. This is still supposed to go through -5 to 5. Now, do I need to know from -5 to 5? No, because this thing just says 0 to 5, so I don't even care about this. But this region should be exactly the same, congruent even if you want to use that word, as that region over there. That's still 4. It just lifted up 2 units. Now, if it lifted up 2 units, what that did is it just built a little, maybe a pedestal. Think of it that way. It's built a rectangle underneath your shape that now needs to be included in the area. You guys know how to find the area of a rectangle. Tell me how. Length comes width, base times height, if you guys want to do that. So certainly your area is the 4, that stuff at the top, but then it would just be plus 2 times 5 or 10. So would you guys agree that we should get 14 for part A? Does that help you a bit? Maybe? No? Okay, that's fine. But that's how we end up with 14 for that one. Part B, keep going. Or am I okay with part A? All right. Now, I personally think pictures make a big difference here. Remember what this said. You guys all told me this moved it 4 to the right. What happens if you guys see, instead of +4, instead of parentheses, what if it's, or excuse me, instead of -4, what if it's plus something? Excuse me, move it to the left. So when you guys are looking at B, it says, and don't worry about this -2 to 3 business. I just want you to take a look at this part that I'm going to underline. See that part right there? What's it tell you to do with your graph? Even though they didn't give you a graph to start with. What's that tell you to do? Shift it 2 units to the left. Same height, just shift it 2 units to the left. So our original shape used to go from 0 to 5. If we shifted 2 units to the left, doesn't that start it at -2? And then wouldn't it end at 3? So isn't it still the same width? Agreed? So we're just going to draw the shape, and again, the shape I'm drawing is supposed to be the same as the others. Isn't the shape still an area of 4 units, this whole area? It just shifted it to the left too. It doesn't change it any. we move it below the x-axis, then it's going to make some of the area become negative. But if we just move it to the left, the reason these numbers changed is because if we move from 0 to 5 and scooched 2 units to the left, 0 is going to turn into -2, and 5 is going to turn into 3. Does that make sense? Remember, your original graph, the first quadrant, goes from 0 to 5. So if we go to the left, 0 is going to turn into -2, and 5 is going to turn into 3. Does it make it more sense to you so far? It's almost like, I don't have a good analogy. It's not really that ridiculously difficult, I don't think. Okay, now, to get to C and D, I will still draw pictures with you. But what we need to do is review a little bit of vocab. What does it mean for something to be an even function? It should tell you guys something about your graph. What kind of symmetry does your, good job, nice work. Okay, means it has y-axis symmetry. And for D, it tells you that you guys have origin symmetry on the function. What kind of symmetry does that mean? I answered my own question, try it again. Okay, D says it's an odd function, so that means it has to have origin symmetry. Now, let me just play a little bit with this. If my graph looked like this, went from here over to this way, and I said to you guys, can you draw me the left side if it has even axis behavior or y-axis symmetry? Can you guys draw me the left side? Would you tell me what to do? So what would the left side look like? Let's pretend this is the point 1, 2. What would the left side look like? Which quadrant would it be in? Top left or bottom left? Top left, absolutely. And what should it do? It should do that exact same thing and then go out like that. Are you with me there? Okay, so for part C, if it says there's an even function, I'm going to draw this kind of small. This goes from 0 to 5, and I've drawn my picture and I've said it's 4. And then what's that tell you guys about 0 to -5 or -5 to 0? It's also the exact same thing, and more importantly, it's also 4. So what should your answer to be? What should your answer to C be? 8. Does that make sense to you? Okay. Now, if I said to you all that this function that I drew the right side of, instead of in part C, in part D it says it has an odd function behavior. What's odd function mean as far as symmetry goes? Origin symmetry. So you guys know that means that it would go into the opposite quadrant and do the opposite shape. Agreed? So according to this then, if I draw a little picture here, remember our 0 to 5 looks like that and the area is 4. And so if it's an odd function, then that means that you're going to go down into the third quadrant. What area would you find below the x-axis area? Negative. So that means it's exactly the same shape. It just has opposite area in sign. So what's the answer to D? 0. Nicely done. So this answer was 8 because you'd have 2 of them on the upper side of the y-axis. You just add 4 and 4. And the answer for D would be 0 because they would equal the opposites of each other and they would get rid of one another. So does that seem easier than it maybe did when you read it and you were like, dang it, I need the function. I need to see the graph, and you actually don't, as long as they give you some basic information about your function to start with. Although when you first look at it, you're probably like, I can't do that, why'd you give it to us? Doesn't make any sense. So, if you guys were about to ask me about number 11, then I'm guessing we're going to take a look at 15. And it might be the case that 20 was easier because they gave you some pictures, and you might have been feeling a little bit more comfortable. Do you want me to look at 15 with you guys?
Yes, please.
Okay. So, again, go ahead, ask your question.
Were these questions looking at the properties that we wrote down?
They are a little bit, you'll see a little bit more in number 15 with the 3.
So I was trying to look at this
Yeah.
that we all wrote down.
Yeah. Yep. Okay, so in number 15, it says from -1 to 1, your area is supposed to be 0. Now, please look at the very last picture that I drew. Remember when we did this, the area from -5 to 5 is 0. That certainly doesn't mean that you just have a flat line at 0. Do you all agree with that? Do you see what I'm saying? It might mean that you have exact opposite areas in both of the quadrants. So I'm going to draw, I want you to think of that. I'm just writing down the given part of number 15. And I tell you that 0 to 1, the area from 0 to 1 underneath the function is supposed to be 5. So we can draw whatever kind of picture we want. Let's do this. In the first quadrant, I'm drawing this over here. We obviously need to draw the graph so that the total area is positive. Now you could get creative and fancy and draw so that some of it's negative, but let's just draw something where you just, I don't know, have some kind of positive area and say, ta-da, your area is 5. Don't you love my little crown there? Looks like Burger King crown, I don't know. But you get the idea. All they told you is there's a function up there between 0 and 1, and the area is 5. All right? How we doing? Okay, now let me ask you guys a question. Because of the second, actually the first piece of information that they gave me, this one right here, they said that if I add the areas between -1 and 1, I'm supposed to get 0. So without even telling you any information about this, how big is the area down here? It has to be -5. See how much you already know just by those two things? Wouldn't those have to be 5 and -5 opposites so that they cancel? You with me there? It's not as hard as it seems, right? You're like, yeah, this, I think I'm getting this. Okay, so let's take a look at part A. Now, part A, ladies and gentlemen, is what we just did. It says try to find the area from -1 to 0. You just deduced that with me. Doesn't it have to be -5 in order for those to cancel? So you're getting it. You're totally getting it without even having a function to do the area under, which is impressive. Aren't you proud of yourselves? Yes, we're getting this, but it's Monday, so we're tired, and we're not gonna act like we're excited. Even though we really are, internally, we're screaming with happiness. We're not, because you guys are just snowed in. Okay, B. If we take a look at this, it says, hey, take the area from 0 to 1. So right now, this homework was about really getting used to the notation, because you guys are, it's kind of like learning a foreign notation, a foreign language, with different, symbols, like, wow, this squiggle thing, and what's it mean, and putting stuff together without knowing the function. All right, well, this is what they asked us to do in B. All I did was write it down. So you tell me, have we already figured out these two pieces, and can we already plug them in? Do we know this? Were we given this? Or can we figure it out? Do we know that? Yeah, that's given. Isn't it 5 up there in the given? Okay, and how about this part? Do we know this, or did we figure it out already? We figured it out, and the answer was -5. Now please remember, you've got a minus sign. That's right. You've got a minus sign in the middle, so what should your final answer be? 10. Nicely done. Beautiful work. So you really didn't have to do any other calculus or area finding. In part B, you've already done all the conclusion stuff. You just had to do that part. How's this? Getting better? It's even better. Every time you read it, it's like an even better homework part, right? Yeah, absolutely. That's right. That's what I want to hear. That's good. Okay, part C says, all right, so where are we? Okay, it says, and this is kind of, Josh, what you were talking about. It says 3f of x dx. Now, there were some properties on your sheet from Friday that said, hey, if you have a coefficient in front of that little 3, that's times, you can pull the 3 out in front and then just do the area from -1 to 1 of your function and just multiply by 3 when you get finished. Do you remember that little property? One of them had like a C or a K in it, and it said you could pull that coefficient out in front, just like we did with the sigmas. So if we pull that out in front, I'm going to ask you what I just asked you before. Do we already know this, or have we figured it out? We already know it's 0. So truly, pulling the 3 out really didn't do a whole lot other than show us we already know the answer for f of x, the area underneath f of x. And we end up with 3 times 0, which is still a big fat 0. One of my favorite all-time numbers. Because you don't have to do a lot of math there. If you pull out your calculators to do 3 times 0, you would never do that to me, I'm quite certain. Okay. Now, Josh, D is where this becomes important. Here's why I say that. Notice that D is very, very similar to C. What's the difference? Goes from 0 to 1. But again, the rule is any coefficient can come out in front. And so just like the sigmas, we're going to pull that out in front, and I'm going to ask you, do we already know the area from 0 to 1? And you're going to nod at me because you're like, yeah, that was given. Kind of like in proofs in geometry, only you're not doing proofs. It just was one of the pieces that was given. What was this area? This area was 5, right? So we just have to do 3 times 5, and we get an area of 15. So now, please tell me, if you feel like 11 and 15 are like, we get those. Beautiful, beautiful, beautiful. Hopefully you can now see why, on this piece of paper, I did not make you do all of them. Because if you look at 12 and 13 and 14, they're exactly the same as 11 and 15. Do you see what I mean? They give you functions, they give you information, and they ask you to try to find different areas and information like that. But again, it's similar in that they didn't give you the picture, and if I had said do all of them, you guys would have come in here with 6 questions instead of 2. would now still probably understand just as much. So those are still like, we could do them if you're really still stumped, that's kind of why I saved them. But you all seem to be catching on to this rather quickly. I had a feeling that you would, being that you guys are as intelligent as you are, yes?
Can you still go over 20?
Absolutely. Is there a certain piece, part of it, or all of it? You tell me.
All of it, and as you go, I may.
Yeah, yeah, because sometimes as we do a problem like number 20, and number 20, I will be giving you a definite free response question. Gosh, geez, there are many, many, many that look kind of like this, where they give you a weirdo shape and it's cut into pieces and say find the area. Now, I'm gonna do my best at giving you the sketch that you guys see on your sheet. What you are supposed to understand on your sheet is that from -2 to 2, this graph is supposed to be the bottom half of a circle or a semicircle. Sorry if my graph isn't oh so beautiful, but hopefully you guys get the idea there. And then over here on the right, it appears that the graph goes up to the 0.42. It's labeled on your picture, and then comes down to 60, so we know what kind of shape that is. And then over here on the left, be careful, it doesn't go down as far as the graph on the right side goes up. There is a little shape, and I believe this little line right over here, they even labeled it for you, is -4, -1. How am I doing so far? Now, you guys, it's totally up to you how you want to do this, but you may want to do this up front ahead of time. Before we do any, and put my sheet down, before we do any of the actual calculus they gave me, let's just find the areas of these pieces. You guys know how to find the area of a triangle, I'm completely certain. Tell me, share it with me. 1/2 base times height. Now, the only other thing we need to remember, of course, is that areas below the x-axis, fill in the sentence for me, are negative. Okay, so if we just want to do the area from -4 to -2, let me draw a little triangle down there, or draw a little arrow. It would be 1/2 times the base, which would be 2 units, times the height, which would be 1 unit. So I get 1 unit, but we would make it -1 because it's below the x-axis. Are we doing okay with that?
Yes.
Okay. Now, let's take a look at the area inside a semicircle. And I say semicircle, meaning it's half of a circle. How do you find the area of a circle? Just a plain old circle, guys. Pi r squared, so this is gonna just be once I do that, I'll have 1/2 of that. And it's totally fine to leave pi in your answer, completely acceptable. In fact, I'd recommend it. So how big is the radius in this little semicircle here? You can look at it in any direction you wish. 2 units for the radius. So this is gonna be 1/2 times pi times 2 squared. What are your thoughts, ladies and gentlemen? Just 2 pi? So this, when I say this, what I'm talking about is the semicircle. Should it be a negative or a positive 2 pi? Negative, because it's below the x-axis, don't forget that. Areas below your x-axis, you're gonna have a negative pointing, yes?
I was just confused on the answer because I was thinking of like the unit circle, I was like, well, isn't just 1?
But this isn't the unit circle
I have
because,
it's 2.
yes,
That's
indeed,
why
that's
now
indeed,
I
so
get it.
that may be it. So you did understand what you were doing.
Yes.
And then the triangle on the right side would have an area of 1/2 times, how wide is it, guys? Like this part right here, nice job, 4 times 2. Would you be okay with just 4? So this area up here is plain old, it's the only area that's actually positive, right? Okay, I think it's probably good to just do those, knock them out of the park first, and then we'll go back and do the calculus stuff. And you will find, I think, once you're able to interpret the calculus, this probably won't be as bad. So we're on number 20. 20 part A says, please find the area from 0 to 2 underneath the function above the x, or between the function and the x-axis. So between 0 and 2 would really technically just mean this. So is that -2 pi? No, tell me what it is. Yeah, exactly. It's just going to be 1/2 of -2 pi, or negative pi, right? Because it's just the right-hand side of that semicircle. And it's negative, tell me why is it negative, guys? It's below the x-axis, exactly right. How's that? Good? It's probably good that we did all of our puzzle pieces and found the areas first. Okay, that's part A. Part B says, and I think we've kind of done this one. You tell me, interpret that for me. That's finding the area from where to where?
2 to 6.
Do we already know that? If I label my x-axis, we do. What did we get? 4. Yep, beautiful. Everyone good with that? Because again, we did our areas first. I thought it might be helpful if we did that. Just going like, oh, I got this. I could teach this.
It makes more
Wait till block 3B comes in and we could just teach them all. We'd be really good, be good. Part C says go from -4 to 2. And sometimes, again, one of those properties, like Josh talked about, was adding the areas together. Exactly what we did when we did with the rectangles. So if we're looking at the graph, we're going from -4 to 2. -4 to 2 means that you're adding, and I'm gonna do this in shapes, you're adding that little rectangle over here, plus from -4 to 2, you'd also have to do a semicircle at the bottom. So does my little stupid graph or picture equation make sense to you? It just means you're gonna have to find the area separately. Well, we already did that, right? What's our area of our little triangle below the x-axis? -1. And what's our area of our triangle, or our semicircle? -2 pi. And ladies and gentlemen, I'm leaving it like that. Don't do decimals if you don't need to. Leave it like that. That's good. So this is becoming like clouds are clearing. They're like this. Okay, D says, please find, I don't know if it really says please, but it does say find, from -4 to 6. Ooh, wow, that's a jump. Okay, from -4 to 6, do we already have all the components that we need to find our area? I got some nods, okay. Help me out, so what all am I adding? Let me ask that. I like that. Every single shape we have up there, right? All of them. So the baby triangle was -1, I like that description, that was good. And then -2 pi was our semicircle, and then over on the right side, 4. So to clean this up, you guys might want to put 3 minus 2 pi, but again, I don't think I'd do anything more than just that. Isn't it okay? Is this a good way to write it out, like all 3 pieces? The baby triangle, like Isaac said, semicircle, and the big triangle. It's just that. How are we doing? All right, now, we're now the ones that make you think a little bit, right? These are the head scratchers. So if we take a look at E. E, oh my goodness, what in the world is this absolute value business doing? What does absolute value do? Now, don't recite what you first learned. It takes the positive of a number. It means how far is a number away from 0. And a number is always a positive distance away from 0. So what it does is it takes your points and asks how far is it away from 0. Essentially then, graphically, what's going on is that your picture is going to have all of the positive y values exactly the same. So this shape is still going to end up with 4, and it's still going to be here. Now, what's it going to do to all of the points that are in between -2 and 2 on the y-axis? It's going to make them positive. So it's going to make the semicircle appear on the top of the graph. And then what's it going to do with our little baby triangle over here? It's just going to make it go up like that. So you already know the areas. You just need to know that when it flips above the x-axis, what changes? Yes, I would agree with that. The signs change, right? So our area for this one over here, our baby triangle had an area of -1, so it's now 1. Our semicircle on the inside had an area of -2 pi, so it's now 2 pi. So if we add those together, am I good with writing just 2 pi plus 5? You do that in your head? Not too bad? All right. Now, F kind of gets into what we did at one point earlier with, I don't still have that picture on the board now, but I think that's because I erased this and put this stuff up here. Okay, F says, please consider the area, again, I'm assuming that it means please, to go from -4 to 6, same area, but add 2 to it. So what happens in math when you take a function and add 2 to all of your y values? It shifts them up 2 units. Okay, so I'm thinking of my original graph, and maybe it's good for me to go back to this shape right here. If I have to take this original graph and take all of the points where they are and raise them up 2 units, then our semicircle has a point over here. It's now 2, 2. And then over here, -2, 2. And so the semicircle would look like this. How we doing there? Okay. And then over here on the right side, this is 2, 3, this is 4, 5, 6. Now, let's look at how much this went up. This went up 2 and over 2, right? So from here, up 2 and over 2, there's your graph here, up 2 and over 2, there's the graph here. So here's our shape right there. How am I doing? sure about you guys, this would be one way to do it. It shifts the graph up 2 units. The graph that I did earlier today with you, where we like shoved the graph up and we got like a rectangle below it, seemed pretty easy to do. But what I'm supposed to do now is find the area between that and the x-axis. And I don't know how easy that's gonna be. Here's why I say that. This isn't really lined up well, but I need to find this area, this area, this area, and then we can break this into pieces. That looks really kind of confusing to me. Would you agree? I don't wanna do that. I'll be flat honest. So I sure as heck wish there was a different way to do it. And so that's what I'm gonna ask you. What if I went and said, you know what, let's split this up. Let's do the area of f of x between -6 and 4, because we know that. And let's split up that, and then do the area of a separate function that's just 2 from -6 to 4. Wouldn't that be easier? Don't we already know what this is? The area already. Well, isn't that what we just did in E? Because we can do these separately. We can split them up and do the areas separately. We already know the answer to this. This one was 2 pi plus 5. Are you in agreement with that? Copying it down from E. Easier to do than what I
No,
drew?
that's the absolute value.
I'm sorry, that's the absolute value. My
D
apologies.
is the answer.
Where's for, I didn't write it down. What was it again? Say it again, 3 minus 2 pi? Okay, sorry, that was the answer for C. So, D, sorry, D. And I erased D, okay. And then, what's this? Well, this would mean, if I sketch it, this means if your x-axis is here, you have a y-axis, or line that goes to your y-axis from -4 to 6, and it just means find the area. So how big is the area? How'd you get 20? Nice job. Length times width. So all we have to do is to take 3 minus 2 pi and add 20 to it, so I get 23 minus 2 pi. How's that? Is that any better? So sometimes there's more than one way to look at something, where one way is like, ooh, I don't think I want to consider that, and the other way is like, oh, much better. Just split them in pieces and do it that way. You like the second way better. We could still do this, it just would be tedious and more than we need to do at the moment.
So is that basically just like the calculus way of like drawing a rectangle like from like this 2 pi and 10 y and just subtracting the shapes out?
Yeah,
Okay.
yeah, exactly. The calculus way on like this. How would you want?
I'm still confused on how that like works out.
How that works out?
Like I understand that you're like breaking apart that equation and then like doing the sum of those or whatever it is for those.
Let me see if I can
But
answer your
like
question.
visually, I don't understand how it fits into the area. Because all that curves and stuff.
Okay, well, let's see. I can't look at that one, let's look at this one. Okay.
Actually, no, I get it.
This is still your basic shape.
Okay, I get it. It just like you're like. Okay, I understand. Never mind.
Totally different way to look at
Sorry,
it.
I just looked at it wrong.
Okay,
I just didn't want it.
okay.
Like cutting out like the circular shape. and
Yeah,
stuff, like
yeah.
getting the area. Like,
Yeah,
the
you'd have to
shape.
find, because when we do this little symbol, it's the area underneath your curve and to the x-axis. That's why no longer is it gonna be the circle. It's good, well, you could look at it, like, if I had to find it, Josh, I'd take this rectangle and subtract out the circle,
Yeah, that's
and
what
that's how I get the leftovers.
Yeah.
So I could still do it, it just would be more of a headache.
Yeah.
Still completely doable. And I still have some very serious looks from some folks in the room.
Serious?
I'm trying to, so the graph you drew there where they're upside down.
That just has to do with E, this one here.
Oh, okay.
That's because E has this absolute value stuff on it. It doesn't have to do with F. F is where you add each of your original 3 pieces and then also add a rectangle of 2. Because F is, part F is what I'm trying to say. It says go from -4 to 6 and your function is f of x plus 2, but we're allowed to do the areas in pieces. So let's do the area underneath the function or between the function and the x-axis from -4 to 6, because I already know that, I already did it in part D. And then let's just do the area of y equals 2, which is a flat horizontal line at 2 from -4 to 6. And that's just a rectangle. It gives you a width of 10 and then the height of 2. And so that just adds 20 onto your answer for part D. What do you mean by taking away the function?
Yeah, okay.
Okay,
Like if you look at the picture and like you imagine a 10x2 rectangle, and then you like subtract the area of that little triangle, subtract the area of that circle, and then subtract the area of the triangle. Or add the area of the triangle. You know what I mean?
I think so.
Like instead of looking at it as you're finding like the shaded area, you're like finding the rectangle and then subtracting what's not there. And then adding the triangle on top, I guess.
I agree with what he said. Now, whether that clicked with you or not, I'll explain what I mean by that.
I get it.
Okay, so this was our, remember, that was like our teeny tiny little triangle. And that used to be 1 unit below the x-axis, right? But it got moved up 2 units above the x-axis. So this point right here got moved up 2 units, this point got moved up 2 units. So this is now up here at 2, so this looks like this. And then this circle now goes like this. And then this goes up the same number of units and down the same number of units. So I want you to look at this. So essentially what it did is it did y equals, like it moved this up to here, it gave everything a facelift. Do you know what I mean? Like where your x-axis used to be, the x-axis used to be right about here. Not right about, it flat out did. It looked like that. You sort of see what I'm saying there? So what's happening in this case is we need to find the area underneath, we need a new color. Underneath the shape between it and the x-axis. Now, if I do that, probably an easy way for me to do this, and this is the part that I think is hard to see maybe. Obviously, we already know that baby triangle had an area of 1, right? And then this gives us a rectangle that wedges it up with a height of 2.
Okay.
Now, I need to find the area underneath my graph, and so this is the part, I think, guys, that's the hardest. Are you with me there? That whole rectangle, if we go from this point to this point, we have a width of 4, let me just do this down here, you agree? And a height of 2. But obviously, that's not what's shaded. What's shaded is that rectangle minus the area of the semicircle. Now, the area of the semicircle was how big? 2 pi. So this area here and here is really going to have an area of, let me just put 8 minus 2 pi. That's going to be that little wedge added with that little wedge. You follow me? And then over here, I'm going to still need to take my area, and I already know that's 4. Then I'm going to get a rectangular area that's obviously 4 times 2 or 8. So that's going to be 4, and that's going to be 8. It just would be harder to piece it into the little segments and do it that way. So sometimes there's a benefit to being able to realize that you can just do your regular old one and then just do 2 and make that a rectangular area and then find it like that. How's that? Better? Okay, so let's do this. All right, on your papers, we are not doing 16 through 19. You did not ask me about 2, even though I corrected that one. So what I want you to do today is to do 12, 13, and 14, same sheet. So you have about 6 minutes left in class. If you don't finish it, you can finish it for homework. And this class is doing really well. I still need field trip forms from Danya. Danya, listen, I need your field trip forms. She's not paying attention, someone wake her up.